Hi there. Hello, everybody. This is James Claycomb from the Department of Mathematics and Physics at Houston Baptist University. Today I'll be talking about superconducting fault current limiters as well as non-superconducting fault current limiters. So the topics that we're going to be talking about today were fault current limiter simulation concepts. Then I'll be talking about specifying superconductors in QuickField. Then we'll perform some AC fault current limiter simulations as well as time harmonic fault current limiter simulations. And also fault current limiter models with both XY and RZ symmetry. So the simulations that we're going to be doing today, we have the inductive fault current limiter simulations using superconductors. And also there's a fault current limiter based on core saturation and desaturation that doesn't necessarily involve superconductors, as well as resistive fault current limiter simulations. So those are the three types of fault current limiters we can simulate. So the QuickField features used in the simulations, we'll be looking at problems in AC magnetics, as well as transient magnetics, AC conduction, transient electrics, and these models, some of these models will be modeling the nonlinear BH characteristics of ferrites, and also the nonlinear JE characteristics for nonlinear electrics, transient electric simulations, as well as coupled electric circuits, and finally we'll conclude with a coupled heat transfer problem. Once again, the models will be both with XY or RZ symmetry. So I'll briefly discuss the concept of the inductive fault current limiter. In the normal state where you have normal current flowing in a coil, the superconducting tube here is going to screen the field from some high inductance element of the fault current limiter. In this case, this is an iron core. We're also going to be doing examples where we have a secondary circuit here. So in the case of a fault current, that's going to drive the superconducting element here normal, and there's going to be some coupling to this secondary element here, thereby reducing the current in the primary coil. So we want to protect equipment and so forth from these surge currents. So here is a supplier of the fault current limiter tubes. This is a typical type of tube supplied by CAN superconductor. It's a BISCO tube, and this is some of the diameters and lengths that they supply. Critical temperature of the tube is 108 Kelvin. So when we're specifying superconducting regions, QuickField, it depends on the type of superconductor, whether it's a simply connected, where we have a superconducting disk. In that case, we have we can use a zero normal boundary condition or extremely small values of permeability. If we have a multiply connected superconductor, such as a tube, the boundary condition is zero vector potential. Now if we're modeling the nonlinear BH characteristics of superconductors, we have to be careful whether we're specifying a simply connected or a multiply connected element here.